I'd like to give my perspective on how I see sort of the future of urban mobility in a smart city of the future. So I've been doing. My name's Stuart Worrell. I'm a researcher from engineering, and my sort of area of expertise is autonomous vehicles. And so what we really look towards is how do we expect to move around in the future? When we start to look at how we move around in the future, I guess everybody has a different sort of imagination of what the future of mobility what might look like. And you can sort of imagine the Jetson cars and these things. But when it really comes down to it, that kind of vision of everyone having their own sort of flying car just doesn't really scale very well. So what we really look at is what do we expect to do in where do people want to move around to? And so we look at different types of spaces. For example, you might consider a campus like a university campus, or maybe an area like Olympic Park, or somewhere like a retirement home, or somewhere like a construction site. And all of these types of spaces have some things in common, and that's people need to move to and from these areas. The way that we sort of see this is that the bulk of the transport is going to be supported by public transport. The best way to sort of scale interactions with people moving around in a large city, in a smart city, is to have smart transportation. But the problem is that when you get off the train or off the bus, you need to then get that last part of the journey towards your destination. And these days is quite a nice, pleasant way to move around is to walk for the last part of your journey or to ride a bike. But for some people and in some circumstances, that's not really an option. And what we're really looking towards is other solutions that we can add to the mix of how people might be able to move around in this kind of futuristic city. And the way that we sort of see it is that there's a capacity for autonomous vehicles to work in this space. We have some platforms that we developed at the University of Sydney, and you can see them on the screen there now, which have an array of sensors that we use to be able to detect things in the environment, to make smart decisions, and then to operate safely. And we're really looking towards this last mile transport. So not moving people like all the way across Sydney, for example, but perhaps more or less taking someone from a train station to somewhere on campus, or around in that kind of scale of things. So from an engineering perspective, which is where my background is, we're really looking towards solving the situation awareness problem. So you start with building up layers of understanding of the environment, and that starts with understanding your location. So localization is the key. We do a lot of work in localization in urban environments. So understanding not just where are the roads, where are the buildings, but also what's the meaning of those types of areas. A road means something very different than a shared space, than a pedestrian area. And so understanding those kind of contexts is very important. Then actually using perception to understand who's in our environment. So it might be cars, it might be people. We use things like LiDAR cameras to fuse that information together to understand what's there. And then once you sort of take this information and then try to work out what's going to happen in the future, then you can start to make decisions about where to drive the car. So the context is very different for something like this, which is a shared space, like a pedestrian area. You can see someone about to cross the road, compared to this, which is a road space, and you can see a car who's about to turn a corner of an intersection. But then even building up to very, very complex scenarios where each person in this environment probably has a very poor understanding of the world around them. So we do some work in, here's an example of some of the things we're doing. We have a car driving by itself and a pedestrian who's about to walk out in front, and the car has to make some decisions about what it's going to do. They have to look at the person, they have to understand where the person's going to move to, and then what the future trajectory of the car should be. So you can sort of see the kind of work that we're doing is actually looking at how pedestrians interact with vehicles, or how they can interact with vehicles. And what this really builds to is what do we think is the end goal? What are we really trying to achieve here? And one of those things is to be able to incorporate the smarts into the decision making of the vehicle that could make a decision to distinguish between the type of thing on the left and the type of thing on the right. Whether it's a child, or whether it's a child by themselves chasing a ball, or whether it's a child being supported by an adult.